Hey guys, welcome back to my videos. I'm sure you're enjoying them because they're brilliant, but forget about that. We're doing maths in this video, and we're doing Core 1 Pure Mathematics. This is section 1.1, Algebra and Functions. This video is hopefully going to help bridge the gap between GCSE and A-level. So this is more of a recap of GCSE stuff with a little bit of incorporation with some A-level notation and some A-level concepts, but ultimately it's supposed to bridge the gap. But anyway, I'm not going to waste your time. Here we go. What we're going to cover, easy. Indices, surds, functions, polynomials, discriminants, simultaneous equations. In that order. I'm going to put timestamps below in the description, and I'm also going to try and section off the red bar where you can skip to certain bits, and each one has its own little title. I'm not sure what that's called. But, you know, I've seen some I've seen some big YouTubers do it, and I'm going to try my best. I don't know how to do it yet, but you know, hopefully by after I've recorded this, I'll know how to do it. I'll look it up. If I can't, I'm definitely going to put timestamps in the description. So anyway, indices, simple indices. So if you just allow me to get my laser pointer right here, I'll go over the indices. You should really know the majority of these, and even some of the ones where you look at it and you're not quite sure, you do actually know it. It's just written in a slightly different way. So these three here, a to the power of m times a to the power of n, just equals a to the power of m plus n. Same for divides, where you just now subtract, and if you put them in brackets or parentheses, whatever you want to call it, it's now times. Same for these two as well. As you can see, if you just have a times b all over all to the n in brackets, then you just times each one by n. Well, not by n, you set it to the power of n rather. And same for this one really, you just set each term to n. Now the only problem with this is, if you just let me get this pen, when I was trying to make this, I was trying to make it so the brackets looked like that, but for some reason it just didn't work how I wanted, so we'll make do with this. But you understand what I mean, hopefully at least. No, of course you do. Right, so these three here really, these two to more greater degrees, they look kind of foreign, I guess, but really they're the same as in GCSE, they're just written slightly differently. So you know that anything to the power of half is just the square root of that thing. Well, you can generalize it, so anything to the power of 1 over n is the nth root of that thing. So that, you know, that's really interesting, to be honest. And then with this one, you know that anything to the power of -1 from GCSE is just 1 over that thing. Well now, it's just as simple, you just generalize it again, so anything to the power of minus n is just 1 over a to the power of n. Now, I've just thought about this, and I think it would be nicer if I just demonstrated with one. I'm not really good at drawing things, but I'll try my best, so if this does look a bit not great, forgive me. So a, oh, that actually looks not bad, to be honest. If we substitute in if we substitute in 1, like you know that a to the -1 is just 1 over a, but you know, if we substitute and go in the way this method is, it's just a to the 1. Well, if we take this out and you do a to the 1, well, a to the 1 equals a. But say you wanted to do -2, right? So if you just take this out again and do it to -2, you go a to the -2 equals 1 over a squared, right? And it goes on like that for all of them. And I'm actually quite happy with the way this has turned out when I'm drawing it with my maps. This is the first time I've tried it, haven't rehearsed it. It actually worked quite well this time. Last time I didn't bother trying to do this because I didn't think I'd be, you know, it didn't work. Anyway, with this one, this is probably slightly unfamiliar because, well, to me at least, I've never come across this at GCSE, right? But it's a to the power of m over n equals a to the power of m, all in brackets, to the power of 1 over n. But if you think about it, this is in some ways the reverse of this. So you kind of covered it at GCSE, but at the same time you didn't cover it in this way. But this is probably the only one you really need to remember, because the rest you know from GCSE more or less. So if we go on to surds, everyone knows surds. Surds are great. So you got root 2, root 3, root 10, root 15, all these surds, these are just examples of surds. But a surd fundamentally is just a root of a whole number, and it's also irrational, as in the value is irrational. So if you were to do root 2 on your calculator and then did the SD thing, it would give you an irrational number, which is just with decimals, right? Okay, so importantly, what you need to know, right, is that this is the only really identity or rule that you need to think about for surds. It's just that the root of a times b is just the same as root a times root b. And you know, we use that a lot when we're doing surds, when we're working with them. For example, say you want to simplify this surd. All you do is you take it, you use the rule, so you find two factors, and you get 4 and 3, so 4 times 3 is the same as root 12, as long as you root the whole thing, and then you just separate them out, as in the rule, where you get root 4 times root 3 still equals root 12. But root 4 can be written as 2, because 2 squared is 4. So if you take the square root of 4, it's 2, so then you get 2 root 3. There you go, you've simplified it. But this isn't the only thing we need to know about surds. We also need to know how to rationalize the denominator of surds. So say this is the surd that we're looking for, and we want to rationalize the denominator. Well, not a problem, because we just times it by the denominator. You do root 5 over root 5, because root 5 over root 5 is just 1, because anything over itself is 1. That's just another rule. But then once you do that, you get 3 root 5, these two times together, and then root 5 times root 5. Going back to this rule, we can see, if we do the reverse of it, we can see that it's root 25, right? Of course, root 25 is a square, 25 itself is a square number, meaning when you square root it, you just get 5. And then here you go, you rationalize the denominator of this surd. Right, functions. Functions is the next topic, and the way I like to think of functions, right, and because it worked so well last time, I'm going to use the pen again. With this bit, kind of just think of functions as sort of like a black box, is what it's called in computer science. But it's the terminology doesn't really matter, but the way you think about it, essentially, for A-level maths, is that functions are, it's kind of like input-output boxes. So if you think back to middle school, where you did things like, you did a plus 2 times 3, and that's what I believe it was called something like to do maths, or maths to do, something like that. I can't remember fully, but essentially, you can just think of a function as some sort of magical black box, where inside this box it takes an input and returns a value, and you can express the value that it returns like this. These are the two notations. This is the GCSE notation, and this is the A-level notation. But essentially, all it does is it takes your value x, and it returns x squared plus 2 in this example. And it's the same for this notation. You need to know both of them for A-level though. So if we just go back to my laser pointer so I can show you properly, for those who are watching on the TV perhaps, because I have got comments about that. But this is Python. It doesn't really matter what programming language this is. You can skip this part because this isn't really on the A-level spec book. But I would say that it's very important because it really helps me sort of visualize and, you know, really sort of digest how functions work, right? And this same method works for a lot of other things that you need to know in maths later down the line, such as it really helped me particularly with calculus. So I really think you should, you know, kind of get used to visualizing it in this way. Anyway, in Python, to define a function, you just do def, but in JavaScript it's function. It doesn't really matter. Here's the name of the function, it's f, just like this function, and as you can see it takes the value x in these brackets or parameters, whatever you want to call it. And although I'm not sure if this is 100% correct, but the way I like to think of it is that there's an internal state in the function, and in the function, in sort of like this box, there's an internal state. And what it does, it doesn't actually modify x, the input, at all. It just squares x, which is what this notation is in Python, where it just squares it. This is, of course, just the same as if you wanted to do x squared, or x to the power of 2. These three things, of course, it's just the same there. So what it does is it takes the value of x and it squares it, but it doesn't set the new value in the x variable. Rather, it sets it to the internal state, right? So then with the internal state, it then increments it by 2, or adds 2, because this is what the function does in this case. Now, this is more of a semantic problem, but I know a lot of people are going to say, oh, well, you could just take this and then just do plus equal 2. That's kind of horrific. I'm not sure if you can make that out, which is correct in Python, but in maths generally, not really. I'm only doing it this way for people who can't program, just so they can read the code without needing to know how to code, because I feel like this code itself here is pretty self-explanatory. Anyway, now with the internal state, what it does is it sets it to the output. So the output is now the internal state. It then returns the internal state, which is what you'd get where you often see things like y equals f of x, and then this bit, and then later on you do f of x equals this, and then that's sort of the way you can think of it, right? Anyway, functions, that's all you need to know for them at the moment. Polynomials, this is the next topic. You're probably thinking, oh, polynomials, I think I've actually heard that in passing a few times. I'm not really sure what polynomials are. And if I were to say, oh, could you put polynomials in a sentence, you'd go, oh, that's a nice polynomial over there, something similar to that. But seriously, polynomials, in general, take this sort of form. So they take the form of a subscript n times x to the power of n plus a subscript n minus 1 times x to the power n minus 1. Same for this, all the way down to a subscript 0. Now, I keep saying subscript n. I think it would rather be just referred to as a n times x to the power of n, but I'm saying subscript just to clarify, especially here, is that these two start on different levels. So a and then it's not just a small n, it's like the power, where this is superscript n, but it's just a small semantic distinction rather. Anyway, what's a polynomial? Simple. Think of a quadratic, as we've got a quadratic here. Well, a quadratic is a polynomial. It's an example of a polynomial with a degree of 2. What's a degree? Simple. It's not degrees as in the angle, but in this case, a degree is, the degree of a polynomial is just the highest power of x that it includes. So the degree of this is 4, the degree of this is 2, the degree of this is 3, right? And with polynomials, you could treat them just like quadratics in the sense you could factorize them, but obviously you'll get the same number of values as the degree. And that's really it for polynomials for the moment. I'll go into further depth later on, but this is just a sort of dipping your toes in the water of A-level maths. That's the way I see it anyway. Discriminants. Right, what's a discriminant? You probably know what a discriminant is. Discriminant is actually quite a hard word to say. Anyway, discriminants. What are they? You probably know what they are, but you just don't know what you just don't know what they are, right? So everyone knows this formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. My favourite formula, actually. I'm sure everyone has their favourite formula. Put your favourite formula down below in the comments if you wish, or don't. It's a free world. I'm not going to force you, but formulas. My favourite formula is this, of course. Anyway, discriminants. Back to the topic. This is a discriminant. We go down here. We pick this bit out. This is the discriminant. You're probably thinking, well, what actually is a discriminant? Well, this value, and this value can be used to give information about solutions without having to solve the equation, which is actually quite useful because you don't have to solve the equation for certain questions. Who would have thought A-level maths, you don't even need to solve the question to get the marks? Honestly, it's crazy. I'm joking. But yeah, that is true. So it can tell you three things. So these are the three possible, I guess you could say, permutations of how a discriminant could look like. So say you got the first discriminant. This one here has two distinct real roots. These are often called roots or solutions, whatever you want to call them. Now, just to demonstrate clearly, these are the two roots, these are the two solutions, right? And I'm sure you're familiar with those from quadratics from GCSE. Now with this one, when it's equal, well, with this one you only have one real solution, or it's also known as a repeated root, meaning, well, there's only one solution. And obviously I'll just quickly circle this here for people with big screens who can't really see my little pointer, but it doesn't matter. Just trying to make sure everyone can see everything properly. Anyway, so with this one, when the discriminant is less than 0, it never actually goes through the x-axis, meaning it never goes through the real x-axis, meaning there are never any real solutions. There are still imaginary or complex solutions, but as you can see, it never touches or goes through, meaning you can't have any real solutions. Anyway, simultaneous equations. What are simultaneous equations? Well, you don't really need to ask that because we got taught it at GCSE, right? And this is just a complete recap of GCSE, right? But, you know, just for people who need a recap, here's the recap. You got two simultaneous equations in this case. Now, a fun fact about simultaneous equations is that you can never solve a simultaneous equation if the number of unknowns is bigger than the number of equations. So here we've got two unknowns, we've got x and y, and we've got two equations. Well, you can solve this one, but say you had 5 unknowns. Say you had a, b, c plus x, y, z, whatever, and you only have 2 equations. Well, you can't solve them. But say you had 5 unknowns and now you have like 10 equations. Well, you can solve it easily. 5 equations, you could still solve it. It's just a quick fact. I hope it was fun. That's why I called it a fun fact, if anyone was interested. Anyway, as you can see, I'll just go through the process of solving the simultaneous equation. First, we get, because we know y equals x plus 1, well, and we know in the second one it goes x squared plus y squared, well, we can just substitute y here, so we can just square it, which is what I've done right now. Once you expand out the brackets, you get this. Group like terms and minus 5 from both sides, so now you've got just a polynomial. Now with the polynomial, you can see it's got a common factor of 2, so you can just take the 2 out and you can divide it all by 2. Now importantly here, you can divide 0 by any number and it's perfectly correct, but if you divide any number by 0, then it's undefined and it doesn't work and you won't get any points. I guess points isn't really the marks, isn't really the, you know, be all and end all, but you won't, and because you can't really divide anything by 0. I'll have a video coming up on that if you'd like, but for this video we'll just say it's undefined, right? So what do you do? Well, you just factorise it and solve. You know this from GCSE as well, as I said. Now you get these solutions, and then these are the final solutions, and if you're wondering how I got from this step to this step, well, you know x is 1. When x is 1, you just use this equation and sub in x. Well, 1 plus 1 plus 1 is, I'm not going to bother writing it out because 1 plus 1 is 2, which is where we got 2 from, and it's the same for this. Anyway, thank you so much for watching. I've actually had a lot of fun making this video, and I'm going to be releasing more videos very soon. I hope you enjoyed it. They're all going to be in this playlist that I'm adding this video to. I've got the introduction as the first video, this is the second video, but obviously there's going to be at least 23 more maths videos coming, so, you know, get excited. It's going to be a lot of fun. I hope you enjoyed it. Give me any feedback that you'd like, and if you have actually reached the end of the video, I believe it was 8% of people reached the end of my last video, so if you were the 8% of people who reached the end of the video, you know, tell people in the comments, say, oh, I reached the end of the video. Fraser gave me a special message, you know, and my special message would be, thank you so much. I've already said everything. Bye.